So hello everyone, welcome back. Before we start, I just want to clarify the purpose of this video, right? The binomial theorem, of course, it's a really common topic, and almost every student in high school knows this. But see, knowing will not help, right? How will it help? Because this video, or rather this entire channel, is all about making your understanding, right? If you know that, okay, binomial theorem, you know that same formula which people use. Even if you teach a parrot that formula, or rather some animal that formula, it will also recite that, okay, x plus n, x plus a whole to the power n, something something, and so on and so forth. Its formula is just, mathematical result, right? So what we are actually going to do here, right, it's really interesting that how did even Newton, people, like, it was discovered by Newton, so how did even Newton think about it? Like, of course, now it of course it's really obvious that there was not some kind of a god, right? That, somehow Newton was sitting, and that god told, okay, I like your long hair, so I'm going to give you this formula for binomial theorem, and then you publish it and then become famous. No, that was exactly not that thing happened, right? It did not happen like that. Okay, so our aim here is to learn that how did it actually come into existence, the binomial theorem. Now, of course, binomial theorem itself is not much tougher, in the sense that the formula itself is, seem very easy to learn, but the process by which we arrive at it is really mind blowing, believe me, and that we are just going to do, right? Hmm. So let's forget everything. Forget whatever you have learned so far. That all these, factorials, combinatorics, and all those, whatever you have learned, all from all your years, whatever age you are, forget everything. Right? Bring it from basic, like zero, maybe middle school level, or even primary level. Right? So let's say we have been given a random expression. Let's say a plus b. Right? So fine. Let's say a plus b have been given. So what more can we do with a plus b? Nothing else. I mean, some a plus b, a combination of a plus b, right? So what you can do? You can either do a plus b whole to the power something, right? So this is a plus b whole to the power 1, right? Um, or rather, what you can do, a plus b whole to the power 2, which basically we call as whole square, right? I'm not talking about a square plus b square. I'm talking about the summation of two terms and some power. So this problem of binomial theorem, it was came, because while solving some physics problem. So that did not come out, from mathematically, that, okay, no, I have to discover binomial theorem. It's really very deep, right? So what happened there was Newton encountered some form of, 1 minus root over x square. He encountered this expansion. Now, of course, this is a binomial whose power is fractional, but currently in this, we are not going to deal with fractional powers. To make, of course, things simplified, we are now dealing normally with, high school level, whatever you are taught, that, okay, integral powers. Now, of course, if you go further, you can extend it for fractional powers. That's no issue at all. But anyway, so let's stay limited to this integral powers. So what you will do, okay, what's the next combination? A plus b whole square. Fine. So a plus b whole square, now you will say that, okay, a square plus b square plus 2ab, but I'm asking you to drop it, like, from ground zero. What you will do? A plus b, a plus b multiplied by a plus b, right? So I'm just speaking from the fundamental, whatever you would do if you were Newton. Like, what's the difference between you and Newton? Literally nothing. Yeah, literally nothing. Yeah. Okay. I know it might sound a bit absurd that, I and Newton are the same, but it's really is just see the process, and you will realize it's not so tough, in the sense that it's not something out of the box, right? People say that this is out of the box and all those, but it's really very straightforward and very creative, right? So just see it, right? So what you will do, a plus b whole square, that's the next possible combination. So we will just expand, like, bracket, and, simply multiply this with this with this. Of course, if you simplify enough, and of course it's a very standard result, you also know it. A square plus b square plus 2ab, right? Please don't go on my handwriting, it's a bit off the charts, but anyways, so that we have a square plus b square plus 2ab, fine, all fine. So now, what if, what's next? See, our aim here is to find some, from generalized form of a plus b whole to the power n. Now, of course, we can't directly go, we can't directly find out it, because we don't know anything. So what we are taking is that we are taking special cases. So it's a kind of idea that okay, if you don't know something complex, break it down into some similar steps. And this works in life also. Like the entire purpose of this is to make you get better at life, right? So if you face some problem which you can't break it, you feel it's too complex for you. So what you are just going to do, you just break it down slowly. That okay, let's take up special case that this happens then this, so I will do this. So that's what we are basically doing. So this is the problem. The problem is this, and now we are breaking it. So we have taken n equal to 1. Now n equal to 1, we can't proceed further any further, right? So now we have taken n equal to 3, and the next, of course, we will take your n equal to 3, of course. Sorry, previously we took n equal to 2, and now we are going to take n equal to 3. So in n equal to 3, what will be it? A plus b whole cube. So again, you will just multiply this with what? A plus b. That's all right, because this is a square plus b square, and if you are going to multiply with another a plus b, that would become a plus b whole cube. So what you will get? A cube plus again, that's a standard result, but if you really want to derive it from the basics, you can. But I'm not writing it, but basically a cube plus b cube plus 3a square b, 3a square b plus 3ab square. So this will what you will get, right? After you simplify, see, you will get a cube plus a square b, and then also you will get 2a square b. So that will make 3a square b. So 3a square b and 3ab square, and of course a b cube. So now we have gone up to n equal to 3. Now this is what generally students remember. So up till now was fine, but now we have to move beyond. What about n equal to 4, right? Can you see? It's not necessary that we need a formula for a plus b whole to the power, and we can of course continue doing it, like again we will multiply with this a, again with a plus b we'll multiply. Or rather, one also thing we can do is that we can multiply this with this also, because a plus b whole square, and if we square it again, then we will end up with a plus b whole to the power 4, right? So now, of course, I hope you understand that if we go on writing a plus b dot 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 all the way to n times, if we just follow the pattern, if we just keep on going, then it's not uh, impossible to get it. So, but why was this made? To make things simpler. Now, I hope you can realize how tedious it is. Like each and every step you have to multiply a plus b. This 3 is fine, but let's say if a plus b whole to the power 20, can you realize that how much work you have to do just for finding a plus b whole to the power 20? And of course then there are higher powers, a plus b whole to the power 100, if you get like. So I hope you realize how tedious it is. That's the reason we are finding this formula. It's not because it's not impossible that we can even do this and keep on doing this until and unless we get to the final expression. But again, it's not very practical, of course. That's the thing. That's the reason we are looking for the formula. So now we will move on to the fourth case, which is n equal to 4 basically. So let's just do it, right? I know it gets a bit tedious and you might not want to get your hands dirty, but really it would be very beneficial for you, right? So let's do it together. Okay, no issues. So what we are going to do, we are just going to multiply this with a plus b, right? So just do it. But of course, now you will get this a to the power 4, a to the power 4, and of course again b to the power 4. So I'm just doing it side by side. So a to the power 4 plus b to the power 4, and then multiply with this 3a square b, a square b, and 3a square b, and if you multiply it with this, you will get 3a square b square, and again if you multiply it with this, so then you will get 6a square b square. So I'm just writing it down. If you can't directly understand what I'm writing it down, how am I making this? Of course you can, if you use a bit of your fast. You need to be a bit of fast so that you can understand what I'm saying. So what I'm saying is that 3a square b square, so multiply it with this. So what do you get? 3a square b square, right? And then again take this term and multiply it with this. So you will get 6a square b square. So 6a square b square, and then you will get plus how much? 3a square b square, and again 1. So is a cube b plus. So that means then you will get 4a cube b, 4a cube b, and similarly by symmetry you will also get how much? 4b cube a, right? So if you can't really understand that how exactly we got this, you can pause the video right here, and you can just stop. You just multiply each bracket by one. If it take your time, but do it. You will get satisfaction after you finish, right? That's the thing. So now we have done a few things. Now of course you do realize that I'm not going to do n equal to 5, because that would be very, very exhausting. So now, what can we do now? Now, of course, it's very tedious. So now we have to find some pattern. And of course, if you look closely, you can observe that fine, a to the power 4. The first term is a to the power 4. The second is b to the power 4. So we were doing, let's take this example, that a plus b whole to the power n, right? A plus b whole to the power n. So we have got this. So now, as you can see, the first term, or rather, if we do it, then we will get a term whose power is a to the power n, and we will also get a term which is b to the power n, right? How am I being so sure? Let's take a simple example. If you can't understand this bigger ones, so come to this, right? This a plus b into a plus b, a square plus b square. So just multiply it simply. What you will get? A square plus 2ab plus b square, right? A plus b whole square. Similarly, if you just remember the formula, then also that's fine. So this is what we are getting, and what we are actually finding. We are finding a plus b whole square. So can you see? Can you see that? Okay, whatever power we have. Now this is just observation. We are just observing, because it's clear that if we do move forward like this, we can, but it's tedious. So can you observe that? Okay, a is the first term, and we have a square, a term of a square, and we have this 2 here, and we also have b square. Now again, by observation, if we say that okay, we have 2 here, so might be the 2 gets multiplied with all these two, so 2ab. So we conclude that okay, maybe a to the power n plus b to the power n plus n into ab, basically. But now if we move forward, that does not actually work. That actually fails here. Like, I mean, this pattern, that this coefficient we cannot find out by just looking at this directly. We will find out how. That's really interesting. We will just wait a minute. It will take a few minutes, a few 10-15 minutes more, but you will really understand it, right? So anyway, so now we have realized that okay, we are going to get this a to the power n and b to the power n term. Fine. Uh, but how we will get this AB? So can you realize that from a square to a, it's like a into a, but just this a is replaced by b. Can you realize it's something like that? Okay, a square is a into a, but it is replaced by, this a is replaced by b. Similarly, b square is b into b, but this b is replaced by a. So that a kind of vague feeling that okay, might be by replacing we can get this 2ab term. Now of course we can't directly say exactly how this works, so we will approach this next pattern. So let me just clearly write it down, and then I'll proceed with the third one, right? The a plus b whole cube, right? So now let's observe. Okay, a plus b whole to the power 3. Okay, so of course we have this a to the power n term, and b to the power n is also there. Now forget the coefficient. For now, forget the coefficient. But how is this a square be actually coming? A cube, write it as a square multiplied by a, right? And with in place of that a, replaced by b. Can you realize this observation? That okay, now we have a cube. A cube, you write a into a square, and this a square you replace by b. So that means you get ab square, right? So that's the observation. And here you have a cube, and you replace the whole a cube by b. So that will be basically you replace a with b. So you will get b cube, right? So now of course, if we look at this a plus b whole to the power n now, it will be much more clearer if we look at it now. A plus b whole to the power n, right? So we will get this a to the power n, of course, first term will a to the power n. That's pure observation. Now whatever, forget the coefficient, there will be some kind of a, let's say, this coefficient, and we will, can you realize the pattern? We have replaced 1a here with b. So that means if we take 1a out, so that would be what? A to the power n minus 1 multiplied by another a, but this a we are replacing it by b, right? So that means, let me use a different color. That means this would become b, right? Similarly, can you predict the next term? The next term would be just a to the power n minus 2. Now we are replacing 2. Now we are going to, again, some coefficient is there. Let's say some dash, random coefficient. We will talk about coefficients later. First, let's talk about the terms, right? So now we will replace 2a with b square. So can you realize the pattern? A to the power n plus a to the power n minus 1 into multiplied by b. So of course some coefficients and all those are involved, and I hope you get the point, right? So that really is not our concern right now, the coefficients, right? So can we write that, okay, this a plus b whole to the power n is some kind of the form. Of course these coefficients are 1, each and everybody know, observe that 1 into a cube plus 1 into b cube, and then we have 1 into a to the power 4, 1 into b to the power 4, each and everywhere the coefficient of the highest power, basically a to the power n, is 1 itself. So 1 a to the power n plus multiplied by some kind of coefficient, we'll first replace a to the power n minus 1 multiplied by b, and it's b, right? And then again some different coefficient, need not be same, because here it was same, that okay 3 and 3, but again in fourth case we can't say it's same, because here we can clearly see it's different. 4 and 6, right? That's the thing. So now again we are going to replace 2a, so that would become a to the power n minus 2 b squared, right? So can you realize the terms, only the terms, don't focus on rest of the things, just see the terms. A to the power n, a to the power n minus 1 into b, and a to the power n minus 2 into b square, and all the way can you predict the last term. The last term would be, some kind of b to the power n, probably, yeah, of course, b to the power n. Now if I ask you some general term, that okay, if you can tell me the general term, then I will be really really happy, right? So this is the first term, you can say first term, and this is the second one, this is the third one. Can you tell me the last one, what would be the last, sorry, not the last, your, let's say some nth term, or rather some rth term, the general term, basically. If you can tell me the general term, I would be really happy. Forget the coefficient, don't only the term. The coefficient you need not deal with now, we will deal with the coefficient but a bit after, because the coefficient is a bit more kind of complex. But first let's analyze the term, right? So rth term, how can we approach it? So can you see that, okay, this is the first term, and we have a to the power n, right? And this is the second term, and we have a to the power n minus 1. This is the third, and we have a to the power n minus 2. That means if we do have the rth term, then we will have a to the power n minus r minus 1. Can you realize that? Why are we having a to the power n minus r minus 1? Because see, the first term was what? N. Okay, first term was r equal to 1, or sorry, just a second, did I mess something up? N minus, just excuse me for a bit, I think I messed something up, just wait a minute. A to the power n, rth term is n minus 1, so n minus 2 minus 1, okay, yeah, n minus r minus 1, sorry, I have messed this thing. So there would be a bracket, right? So can you realize this would be the rth term, because can you see, if if the term is, if we are looking for the first term, then we'll just put the value of 1 here, r equal to 1, and then we will just get a to the power n. And if we look for the second term, we will just put r equal to 2, and then we will get the same term. And of course we have the b as well. Can you realize that these two powers, they add up to be n? Can you see, a to the power n, or what, b to the power 0, so n plus 0. Here b to the power 1, so n minus 1 plus 1, right? So that means it's n. Again here also minus 2 plus 2 gets cancelled out. So can you realize what would be this? So it's really simple. N minus r minus 1 plus this power, let's say some power, is equal to n, because the total power should be, you can say, kind of conserved. So that would be simply how much? We send it to the other side, minus r, so 1 plus r, so that would be it, r plus 1. That would be your rth term, right? I hope I did not mess up this time, but anyways, I hope you get the point. Forget about the term if you feel like, no, I'm not understanding. I might make a mistake here, calculations and all, but I do hope you realize the pattern, right? That okay, a into this, the whole power should add up to be 1, and this is how the pattern goes. So now we have talked about the pattern, right? So let me just clear a bit of this mess, and then let me write the pattern, and then we'll continue with the coefficients, because we have found out the terms. Now we need to find out the coefficients, and if we find out the coefficients, our job will be done forever, right? So let me just do it, and then we'll continue. So this is it. Up to now, you yourself have arrived up to this. Like honestly, it's really all we did was just simple observations that okay, fine. After this, and all those things, fine. So now we are done with the expansion. Now, if we can somehow figure out the coefficient, now of course the coefficient of first two we know it's always one. But now if we can somehow figure out the coefficient of all these rest of the terms, that this term and maybe this term and other terms which will come in the series, then our job will be over, right? So now we are going to do just that. Now again, how can we do? Again, take special cases. Now we don't directly know that how can we approach it. So take special cases, right? So what? How can we take special cases? Let's come here. Let's come here. Yeah. So so finally, let's start with the coefficient, and it's going to be really interesting, right? So firstly, oh yeah, another thing I forgot, that okay, you could have, if we are talking about whole numbers in general, that you could have just taken n equal to 0 as well. Yeah, fine. If you took n equal to 0, then a plus b, again considering it's valid, not, it does not come out to be a equal to b, so that means that will just come out to be 1. So if we talk about in general that okay coefficient, then that would be 1 only. But anyways, let's not talk about it. I mean, I'm writing the coefficient, like I'm going to arrange the coefficient in some kind of a pattern or something, if we can find one. Okay, so let's take the first instance that okay, we have n equal to 1. So what are the coefficients? A plus b, so only 1 is the coefficient, right? 1a plus 1b, so we just write 1 and 1, like just I'm randomly writing the coefficients, right? So we have done this. So now let's move on to n equal to 2. For n equal to 2, what would be the coefficient? A square plus b square plus 2ab, right? So what is the first? First one is 1, second is again 2, and 1. Can you realize what I'm writing? This is the coefficient of a and b. This is the coefficient of, just I'm arranging the coefficient. Can you see that? Okay, 1 and 1. The next one is 1a square plus 2. If you arrange it in this manner, in the generalized format we arranged that, okay, where did that go? A plus b whole to the power 3, a cube plus b cube. Yeah, right here. So I am arranging it this format that okay, a to the power n, for just for pattern it looks good, right? So that's the thing. So if you take n equal to 3 again, so what would be the coefficient? 1, 3, 3 and 1. See, 1, 3 again, 3 again, and then 1 again. So that's the thing. So we are doing that only. But I'm arranging it some kind of a table or something, so that more easier to look at. So n equal to 3. Simple. We are just writing it down. Special cases, right? We can't do anything else. 1, 3, 3, and 1. Fine. And since we have done also n equal to 4 also, so why not write it down as well? We had I had to do so much calculation. So can you realize that first we are going to write these terms and all, and then we'll move on to this. So 1, 4, 4, 6, 1. That would be, sorry, 1, 4, 6, 4, 1. And you realize that how, in what way I'm writing the coefficient. I'm not writing the, here I made a mistake, in the sense that I wrote it in a way that might have confused you, that okay, after this term, actually if we expand it sequentially, then after this term should come, and after that this term, and then this term, and this is the last term. But I have written here the second term, so I have messed up here. But again, going by this logic, by this format, if we do go by this format, then we have this a n, and I'm writing the similar kind of, I'm arranging it firstly in this format, and then I'm writing the coefficients. So now Newton, what the only thing that he did was, he was observing that okay, is there a relation between all this? Because how do we get to the numbers? Now this triangle is very famous in mathematics. It's kind of, if you write a 1 here, then it's kind of like a triangle, forms a triangle, and this triangle is so-called known as the Pascal's triangle. Again, nothing, it's just the observation. It's nothing fancy on all those. It's just observation, right? So it's not as if the name matters much. It's just pure observation. So what Newton did was a bit just observation. Can you see how did it actually come about? One is here, okay, fine. One is here, one is here, and one is here, which was kind of expected because we knew that the first term and the last term will all have the coefficients as 1. So 1, 1, and 1 itself. So fine. But how do we actually get these two? So But Newton thought that okay, if maybe if we can combine this 1 and 1, then what we will get? 2, right? If we combine, so 1 is here. If we combine 1 and 2, what will you get? 3. If we combine 2 and 1, what will you get? 3. And if we, can you see? You can even extend this pattern. Of course, 1 remains as it is here, and club 1 and 3, you will get 4. Club 3 and 3, you will get 6. And club 3 and 4, again you will get 4 itself, and then just 1. Can you realize it's so beautiful, so elegant? I mean, really, this we didn't even expect this to show a pattern. We were just observing, and it just came out, out of the blue, right? So 1 and 1, it adds up to be 2, and then it goes around to be 3, and this is 3 again. And if we again club these two together, we will get 4, and we'll get 6, and we'll get 4 and 1. And now, can you realize that if you can even move on to n equal to 5 without even doing all this? Because previously what we were doing, we were just multiplying it with this a plus b, and so on and so forth. But can you realize we can even now do it without any such calculation? So see, 1 will come here, of course. 1, then club 1 and 4 together, what will we get? 5. Then club 4 and 6 together, you will get 10. Then again club 6 and 4 together, you will get 10. 4 and 1 together, again you will get 5, and then you will get 1. So can you realize, if we do talk about n equal to 5, the case of n equal to 5, then what we will get? If we will get a to the power 5. I hope you can see the entire screen. Yeah. So a to the power 5 plus 5 a to the power 4 b plus 10 a cube b square plus 10. Can you realize it's just decreasing powers? A square b cube plus 5 a b to the power 4 plus b to the power 5. So now we can just extend this pattern, so on and so forth, and we can get, let's say, n equal to 10. For n equal to 10, we can just find the 10th row. For that, we need the 9th and the 7th, 6th, 7, and all this up to this. Of course, now it's much more easier than this. Previously, what we were doing, like we were multiplying each and every term, so that was very tedious. And now we can even just write down this pattern, and it's just a pattern, it's just observation, not as mathematical. Just an observation that okay, if we do like this, we will get the result. So for a few period of time, for a long period of time, this went on, and it was good. I mean, it's really worked. It was much less tedious than before, and people thought that surely it couldn't get better than that. But again, we have Newton. What we can say, we have the human brain, the capacity to think beyond. So let's now deep dive into what actually Newton did, right? So it's really exciting. Just my battery is running a bit low, so I'm just going to plug in the charger, and then we'll again continue. So let's resume. Right. So we have now Newton again went back to the very basic, like the code, like how did it even originate. Now, if we were following the so-called modern society, then we would be just stuck in here. But he went back to the code again, and let us go to the code as well, right? Because we are now Newtons. We are doing what he did at the age of 2024. So let's again deep dive. Okay. I think the ink is too thick, a bit thicker. So let me just fix it. Yeah. So now we have it's 1 second. Yeah. So now we have a plus b whole square. So now we are directly analyzing with a plus b whole square, because a plus b is just nothing to analyze, right? So now we are getting this a square term, which we figured it out, and we are also getting this b square term, right? And we know that the coefficients of both of them are 1. But now, how are we getting this 2ab term? Like, of course, by multiplying it, like this a plus b multiplied with a plus b. So what we get? We get 2ab, right? But can you realize that how are we actually getting this 2ab? We are getting this 2ab by multiplying the a here with b, and we are multiplying the b here with a. So can you see that there are two ways in which we can choose the term ab? Again, if you this ways and all, if this confuses you, like from the combinatorics and all this, forget it currently. Don't think that okay and all these formulas and all, forget it, right? Being back to the code, right? We have a plus b into a plus b. That's what a plus b whole square all is about. So in how many ways can we select this, how many ways can we create rather this term ab. So simply we can only do two things, because if we multiply it with this, it will become a square, which we have already found out. So we can only multiply it with a with this b, so that will come out to be what, um ab. And there basically, so there are two ways, right? Again, if we take here from here, then again another way, so one way here and one way here. So there are two ways, and the coefficient of this is 2. So does that imply that maybe the mixture of, I mean, the coefficients are maybe the number of ways in which we can create it? I don't know. I don't know. Let's find out. Let's find out. Let's analyze for, this was our first observation. Let's analyze for a plus b equal to, sorry, a plus b whole cube. It might be wrong, but why not give it a try? Why, it's worth a shot, right? So a plus b whole cube. So what was a plus b whole cube initially? Just, from the code, a plus b whole cube is what? Simply a plus b multiplied by a plus b again multiplied with a plus b. Again, I have to write all this because I have don't have a stylus, so again bit of financial issues, but otherwise it will keep quicker. But anyways, let's kindly focus on it. So now we are, so see, now of course we know that a cube will come, b cube also we know will come. So what are the terms we are looking for? We are looking for a square b and ab square, right? And of course we did this previously and we found out that it we got 3, right? So yeah, so we got 3. So we did this previously, so again we know that the coefficient here should be 3. But now by our logic, does it match our expectation that okay, might be is the number of ways in which we can select a square b? So how can we select a square b? How exactly can we select a square b? Now again, forget all the formulas that are coming to your mind. Just see the brackets and see the code, right? So a square b, that means we need 2a and 1b. So how can we do that? Probably we'll take 1a from here, 1a from this bracket, 1a from this bracket, and another b, right, from this bracket. So then that will give us one combination of a square b. Basically this a with this, or rather, just a second. I think I drew the wrong arrow, but anyways, here. So we'll take this A, and this B. So that's one combination. What's the next thing we can do? Perhaps we can take this A and this A together. From, of course, can you realize that from one bracket we can at a time we can only take one only. Like if we take A from this bracket, we cannot take B from this bracket, because then see ultimately what we are doing when we multiply A with this some number. First we multiply it with A and then with B. We don't directly multiply A plus B, right? So we can't take this B with this number, right? So from one bracket only one term we can select. So we can select A and A from this bracket and B from this bracket. So that means that is the second way. However, we have another way also. If you look carefully, if we take this A, and this A, the extremes, and the B from the between, can you see there are total 3 ways in which we can select this A plus A square B. And similarly, if you look, it's symmetrical, right? So similarly, if you look closely, then you will find out that you will get this same 3 ways to get AB square. Now of course again might be that it is valid for n equal to 2 and 3, but what if it is not valid for n equal to 4? Let's find out. I think we did it, this coefficient and all. Yeah, of course. So let's just find it out. Why not? It's really getting very interesting. I know it's the video is going to get a bit long, but I know I told 30 minutes, but it's so interesting, just really brilliant, right? I just can't stop myself. Anyways, so a plus b whole to the power 4 is what? A plus b, when I thin it, then again, anyways. So if I could just copy it right here, I have just destroyed that place entirely. Damn, man. Anyways, so a plus b multiplied with a plus b, again multiplied with a plus b, and all those. I don't want to really write, but again, it's for beginners. It's we have to write. I mean, it's to understand so that people can understand. Anyways, so we have these 4 brackets. Now, what we are looking for is that we know that we will get a to the power 4, right? And now, what's the next term we are looking for? We are looking for a cube and b. So, and we know that the coefficient should be 4. Is it coming out to be 4? Really? Let's check. If it does come out to be 4, then to life set. I mean, we have then found out the formula. I mean, if we can choose the number of ways we can do it. So maybe we have to generalize it a bit. That's a bit, 5 minutes task, but rather, let's just clearly see. Okay. So A is A cube B. So how do we find out A cube B, right? Let's take 3A from this and the B from here. Fine, that can be done. Let's take 3A here and B from here. So that's one way, that's the first way, that's the second way. Let's take perhaps this A and this A and this A and the B from here. So that means that's the third way. You realize if you, I mean, it does get a bit complicating because if it's a bit, it becomes a bit difficult to look at the patterns. But let me just show it systematically. First, you take this A, and then you club this A, and you club this. Along with it, you get the B, right? So that means that's one way. Another thing you can do is that probably skip this next bracket, take A from here, A from another A from here, another A from here, and B from here. So that's the second one. And now what? Now what's the next thing you can do? Perhaps scrape this bracket. One A from here, uh, another A from here, another A from here, and another B from here. So that means again we get the third one. And what's the fourth one? Fourth one is you take one A from here, and one from here, and another from here. So that means that there are total four possibilities, right? So one, three, yeah. So for one and three, and then yeah, so four possibilities. If you do feel it a bit confusing, then let me know in the comments also. I mean, now we don't have to go further. If we could have just stopped, we just have to go on further to check that okay, it works or not, and it does. And if you find a bit, a bit complicating, then you can just skip it, or rather, you can just try it again once in your copy. That okay, you can write that okay, how many ways can we choose it? Now we know that okay, ultimately whatever the terms we are looking for, like all these, where did it go? Yeah, the general term, yeah. So whatever these coefficients are looking for is basically the number of times or the number of ways we can choose this term from the the whole expansion, like a plus b all the way to dot 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 n times it's just written. So how many times can we choose this term out of all these multiplications? That's the coefficient, right? So now we just have to figure it out and then it's done, right? So another 5 to 10 minutes and then we will end up with the binomial theorem which Newton did it, and he spent his few years and we have done it, of course. Again, hats off to him, but the thought process I hope you really enjoy, right? Let's just do the final step and then we'll end this video, right? So just a second, I just need to check whether it's recording or not. It is recording, and sometimes it's just gets cooked. I mean I am recording and it suddenly stops. Anyways, so where were we? Just a second, okay. How many ways did I tell here? I told, I think, what AQP and all this. So yeah, I hope this point is clear. I hope I no issues here. And I mean, if you want, you can go further. If you want to look for other terms, I mean, let's. If you want, then I can go further a bit further for beginners especially. Just a second, if I can just clear it off. Let me just clear it off and then I'll resume. So we can even go a step further, right? So if you want to get this a square b square term, so we can do that. So take 2a from here and then 2b from here. So that's one combination. Then take 2a from here and 2b from the remaining one. So that's another combination. Another 2a from here and take 2b from the other two. And now for again the same thing you can do. Can you realize? Because we took the a as first, so we group the a's together. That okay, a square, a square, a square, that term. And now we can even take two b's together. Okay, take 2b and the rest two a's. So that means that's another. And you take this 2b and then that's another combination. The rest of the a's and then another these 2b. So that will no need to worry about all those a square term. If you take b square, then a square will come automatically with it, right? So can you realize it's total there 1, 1, and 1. So both for A there is 3 choices, for B there are 3 choices. So that means total of what 3 plus 3, so that's 6 choices. So that means we have 6 choices to choose this A square B square term from the list of the factors that we will have for this. So now, I mean, it does get a bit tedious and does get a bit confusing. So we'll do it with a similar case or simpler case, for example, which we did with a plus b whole to the power 3, basically n equal to 3. So it's a ideal case. I mean, it has some extra terms, but it's not too complex like this one. So we can deal with that. So let's just do it, right? So ultimately, whatever all those discussions led us was that if I find the total number of ways I can select each and individual term, then I can find its coefficient. So basically, that's it. So just it's a really simple task. Now we need to find the number of ways the term can appear, the total number of ways. So how can we do that? So again, take some case like let's say, as I mentioned, let's take this a plus b whole cube, right? Why not? Why not? A plus b whole cube. Just so tedious. I probably if I could use it again. Let me just rub this off. I hope you don't mind me reusing this page. This anyway. So yeah. So now, what we need? We need this coefficient of this. Like how many ways we can choose. Now of course this is a small power, so we can directly see it, but if it does extend to larger powers, we also saw that it gets a bit difficult, right? So how can we basically do it? So uh, we have total of three brackets. Basically we have total three brackets, a plus b multiplied with a plus b, and then multiplied with another a plus b. So we have three brackets, and we need to choose um, you know 2a from each bracket and 1b. So that means we do get around we did this, and we get three choices. We got three choices, right? So now we are defining. So we got three choices, or three possible options. So that means of course the coefficient is 3. Fine, all fine. Now we are going to define something that okay, there were three brackets and we chose 1b, or rather we chose 1a or 2a together. So let's say 3c something choice, basically some choice 3c2. uh, Random, you could have given it as 3 x2, but we chose for choice, that kind of thing, c for choice. So 3c2, that comes out to be 3. So now, don't treat this as a formula that okay, no, 3c2. Oh, sorry, you can't see the screen, right? Yeah. So don't treat it as a formula that 3c2 is equal to 3. No. We did this and we found out that okay, there are three brackets, and if we club these two a's together, then we'll get this total combination of three times, three possible combinations. That means hence the coefficient is 3c2, or we could have just written 3, but for for convenience purposes, so that we can extend it, we wrote 3c2. And can you realize that 3c2 would be the same as 3c1? Again, the same properties or formulas you learned. How am I saying this? This is 3, right? Not 5. Because see, with this a square term, we get b to the power 1. So that means we can either choose 2a from three brackets, or we can also choose 1b. And if we choose 1b, then automatically from the raised to brackets we cannot we can if we are looking for a square b term, then we'll get this 3c1 term only, because sorry, 3c2. Oh no, sorry, 3c1 only, 3c1. I measured up 3c1, because you are choosing 1b, and if you are choosing 1b, then automatically from the rest two brackets we will choose a and a, and then that would give us your a square b. So that's the thing. So now we can extend it to the a plus b whole to the power 4. So let me just pause the video. I will write the a plus b whole to the power 4, and then we'll see there also. It was kind of lazy to write, so I just copied this image. I hope you really don't mind, but I'm sorry. I had to do it. So, anyways, so what we are doing is that right. Let me just change the ink a bit. Yeah, a plus b, again 4 brackets, a plus b, and a plus b and a plus b. Right. So now we have to select 3a, right? 3a from these 4 brackets. So what can we do? Like previously, as we did that, okay, 4, okay, 4c 3a we are choosing, so that will just give us 4c3. Now this value of 4c3 we will find out. We have found it out, by some kind of formula or by observation, like similar to this. Now I'm not telling you the formula that okay, 4c3, the formula you learned n factorial by some r factorial n minus r factorial. No, not like that. We found out that okay, 4c3. What was 4c3? 4c3 was 4, right? So now we know that okay, 4 brackets and we are choosing 3a at a time. So if we choose 3 at a time, automatically we will get 1b, right? So that's it, 4c3. That's how we are getting 4c3. Now then we are choosing 2 at a time, so 4c2. And then we have defined that okay, we have found out that okay, 4c2 equal to 6. Using all this, then we have reached the formula. The formula itself was not there from the beginning, that okay, n factorial by some r factorial by n minus r factorial. I'm not teaching you a formula, I'm telling you how to represent it. So there are 4 brackets, and you have chosen 3a together, so 4c3. Now we don't explicitly know the value of 4c3. That we will find out using formula, which we will derive later, which I'm not going to do in this video because it would stretch over 1 hour, which is already has. But anyways, I hope that it does get a bit of retention, because people will run away from this. But I realize that. But anyways, so that's the thing. If you have, let's say, let me just clear all of this shit off, right? So if you have another a plus b, so a plus b whole to the power 5, and you are looking for a to the power 4 b, then what would it 5 c 4a together, 5 c 4, and you find out, and I will get the answer as 5. So that's the thing. Now coming out to the general formula, where I wrote the general one. Yeah, just a second, where did it go? Yeah, here, right. So here is the general one, right? So now can you see what is this? Just a plus b into a plus b into a plus b, all the way, dot all the way up to n terms. So now what we actually can see here is that we have to choose. So there are how many brackets? See how many brackets are there. So of course, so we have written a plus b whole to the power n, so of course there would be n brackets. So from n brackets we are choosing how many a's together? N minus 1 a's together for this term, for this coefficient. And automatically, if we choose n minus 1 a's together, then we are only looking for, again, very sorry, the screen is a bit off. So again, as I was telling, is that we are choosing n minus 1 a's together, so that means we'll automatically give 1b only, because we know the coefficient of this one. If we take a again, then we'll get a to the power n, then that's the coefficient which is just ncn, right? So I hope you get the point. So that means this into a to the power n minus 1 multiplied by b. And similarly, if we do look out for this term, then we are getting n brackets, and we are choosing n minus 2 a's together. So this will be the coefficient of this term. So that's the way. So that's how we chose, right? So now we have finally ended our brilliant tasks, right? So now we can write that a plus b whole to the power n, right? We can write it as, we can symbolize it rather, that, and write it as, a to the power n, of course. For pattern we can write nc0 and all those, but nc1, or rather nc n minus 1, you can kind of say, because what would be the next power? A to the power n minus 1, we are to take plus into b, plus nc n minus 2 multiplied by a to the power n minus 2 and b square. So now if I ask you, tell me the nth term, or rather let's say n plus 1th term, or rather sorry, r plus 1th term. Tell me the r plus 1th term. Why I'm telling r plus 1, you will understand, but tell me the r plus 1th term. So simply r plus 1th term means what? N. See, first term was cr minus 1, so nc n minus r, right? If we talk about the r plus 1th term, so can you realize r plus 1 is what? N minus, can you see, this is the first term, this is the second term. In second term we are doing minus 1. So in r plus 1th term we will do minus r, not minus r plus 1. We did this, in the above also, where I messed up a bit, but anyways, so we are doing nc n minus r multiplied by a to the power n minus r multiplied by again with b to the power r, because the whole power is just n. So this is the general term. Let me separate it out, someplace here. This is the general term, and for summation, of course, this is the addition of all these terms, general terms, right? So what we do is we just simply use this summation of this summation, this you can say symbol. This does not mean something crazy. It just symbolizes. So n. So the value of n ranges from what, 0 to n, right? So that's the thing. So this is our binomial theorem, which Newton discovered at the age of 24, and it's, I hope you do get the point that how brilliant we did it. It was not something out of the blue, or it was not something out of the box. It was, derived each and every step from, basics. And again, this formula and all, people will make you learn that, okay, no, this n factorial by some r or n minus r factorial, forget it. It's really nothing. The main core is this formulas and all, we can all, those are applied mathematics, but this is the core. I hope you really enjoyed what I taught you. I mean, it's really very goosebumps, like we finally arrived at this beautiful result, which we have been forced to learn that, okay, that's how it works. I hope you do get the knowledge. If you do have any further doubts, then please let me know in the comments, then I'll try to solve it as soon as possible. I hope you enjoyed. That's my main aim, to make you understand. So see you later. It's already 51 minutes. Um, I know the viewer retention. This video will not get many views because that's what generally happens. But if it interests people, yes. See you later. Good night and bye.